Yeah, let's begin. So welcome, I'm Philippa Jefferies from River Publishers. And today I'm talking to Paolo Di Nardo from the University of Rome Tor Vergata and one of the editors for the River Publishers book series, Biotechnology and Medical Technology Forum. He has extensive research experience in cardiac muscle diseases and cardiac tissue engineering. And today we're going to talk a little bit about his experience and research interests, as well as the book series. So thank you very much for joining me today, Paolo.
Thank you.
So just to start things off, I was wondering what drew your interest to cardiac muscle diseases and this kind of area of research that you're in specifically?
This is a very long story because I started to be interested in all this topic when I was 2 or 3 semesters before my degree at the medical school, when by chance I met a professor a long time ago, who at that time was anticipating what now is quite common, or yes, quite common. At that time, this man was at the same time involved in the clinical work, and he was also involved in a basic research lab. So he had the opportunity to translate, to discuss on both sides of a problem. And I was a very young student, and I was really impressed and fascinated by this story. And so from that point, I continued this, this kind of vision of my, of the topic, that the domain that I'm studying now. Consider also that in 1994, together with a very good friend of mine that now passed away some years ago from the United States, we organized a meeting in 1994 near Rome, where for the first time we launched the idea and the dream to treat cardiovascular diseases with cells. That was the first time. And the large number of scientists that after that year were involved in the last 20 years in this field were young guys with us in this meeting. So it was really a very important step forward in imagining a different future for the treatment of heart disease. I'm saying that because every day we hear from television, from other newspapers, etc., that we have a new solution for heart diseases. Yes, this is, I don't want to say not true, but almost not true, because the treatments that we have, even the best treatments we have for heart diseases at the moment, are palliative. We are not able to treat, to cure the disease, but we are only able to contain the disease. And then when we do not have any other possibility, we use heart transplantation. But heart transplantation is an extremely expensive methodology. In fact, you have heart transplantation only in rich countries. Most of countries cannot afford this kind of burden, economic and technological burden, and so is not a solution for the future. And so we need other kind of treatments or protocols, and I'm personally, I and many others, we are convinced that using stem cells, or even not stem cells, but and tissue engineering, we can, in some decades, I think, we can try to give a solution to this huge problem. Cardiovascular diseases are the first killer in the world. We are very concentrated on COVID at the moment, but the first killer in the world are cardiovascular diseases.
Oh, really?
Yeah.
And I'm interested, what is it about cardiac muscle diseases that make them difficult to, as you say, cure, and we only particularly have palliative care?
Good question, but cardiovascular disease is a very complex number of different stories. Anyway, if you, today, for example, we do not have any drug able to counteract the diseases of the cardiac muscle. When some people suffer from heart attack, what we do, at least in our country, is to go immediately to the emergency unit and they apply a stent. This is quite common now, quite easy. The fact is that the stent reopens the vessel, the coronary artery, but we do not have any treatment at the moment about the damaged tissue, the damaged muscle. We have to say that after years and years, at least from the Second World War, but even before, during which a lot of money, a lot of funds have been spent for trying to understand this aspect, we are exactly as we were. We do not have an idea because the cardiac machinery, the myocardial machinery, I don't want to repeat always the same word, is very complex machinery. And that has a very important characteristics that every 0.7 seconds is like a wheel. After 0.7 seconds, it must go to the same place it was before. Now, to understand what's happening in 0.7 seconds is not so easy. For years, biochemists have tried to understand how the machine was made and what we could do. But they were not able to finalize a lot of things. After that, we had a very good improvement at the end of 80s, beginning of 90s with molecular medicine, etc., molecular studies that allowed us to understand much more about the heart. But at the moment, we are not able to find something that helps us in really repairing the muscle, not the vessel. And so maybe I'm convinced, maybe I'm wrong, that the true solution can be to transplant new cells instead of damaged or suffering cells that we have.
Yeah, and you've spoken about some stem cell therapy, and this year you're part of a paper that reviewed this for heart regeneration. Could you explain a little bit about how you could use stem cells in this way in this particular application, and kind of what the challenges are of this?
About regeneration, you know, all our body is so beautiful, above all during the good season, because every place of our body is continuously regenerated. Okay, our skin, for example, more or less every 3 weeks is almost totally renovated. Our gut, for example, has a different cycle of renovation. And so it happens for all in all places of our body, except for the heart and for the brain. The rhythm of regeneration they have is so slow that is not sufficient to maintain the heart or the brain in a certain condition. For example, today, for what we know, we consider that in your first 70 years of life, only 45% of the cells of your heart are renovated. So it means that half of the cells of your heart will work for 70, 80, 100 years, I don't know, being always the same. There is no material, there is no machinery that we know, man-made or existing per se, that is able to develop such an incredible amount of work without failing, because we have people who are 80 and are in very good shape, very good health. So it means that there is a possibility for the heart to resist for such a long time.
Yeah.
working at the rhythm of zero, a contraction every 0.7 seconds. That is really incredible. Now, the point of tissue regeneration, the true dream is to be able to find a way to fabricate a piece of tissue able to emulate this natural machinery.
Okay.
This is a very huge dream. Of course, we are dreaming step by step. In other words, it will be a lot if we will be able to do something, and then we can improve, etc., because I don't think that at the moment anyone can have a solution for the whole thing.
Okay. And what are the specific challenges using stem cell grown tissue for the heart? Because I would imagine it needs to be incorporated into that whole mechanism, right? Because the heart is contracting all the time.
Okay, the heart is a strange object made of two things and half. Okay?
Okay.
The heart is an object, the tissue of the heart is an object made of a living part that are cells, perfectly matched with an inert part that is called extracellular matrix. Okay. So one of the major technological problems that we have is how to create something in which we can be able to match these two different aspects. Okay. To help this, and this is the half, we can use growth factors, hormones, and other factors and substances that can help, can enhance, can push forward the evolution of this kind of system. So at the moment, there are scientists directly involved in improving the knowledge on the cells and on the manipulation of cells. On the other side, there are people who are involved in understanding how to create something that is inert, that is not living, but is absolutely compatible and helpful for the living side. This is the terrible problem, that very complex problem that we have at the moment. In fact, in my research group, we have a lot of engineers, so material scientists, chemists, mathematicians, more than biologists, because if we do not solve the problem of the inert side, we can have the best cells of the world, but it's difficult to imagine how to use them.
Okay, interesting. That's very interesting. And kind of moving on slightly to looking at the series now. So you're one of the editors for our series in Biotechnology and Medical Technology Forum, which looks at a variety of topics in basic and translational medicine. I was just wondering, just to finish, kind of what do you think are some of the other interesting research areas in this area at the moment? What are you excited about for the series?
The idea of this series, maybe you know that the very original and first idea of this series dates back several years. We discussed for years, then we did something, etc. Now we are very seriously intention to finalize this idea. And so I think that what we are trying to do, the forum and the books, etc., could be helpful, because there is a gray area between pure biology and pure engineering. And in this gray area, there are very few publications. The communication among scientists is not helped a lot by the systems we have at the moment. So maybe a multidisciplinary or a multi-domain tool to help scientists who are living in the middle, like me, between biology and engineering, could have a relevance and could be meaningful.
Sure.
This is why we had this idea.
Yeah. And do you think this is a common trend, that in medicine, things are becoming much more multidisciplinary, using engineers, as you say, chemists, biochemists, the whole range of people.
Yes, I'm absolutely, we are in the need of all these people, all this knowledge. Medicine per se is, in my mind at least a century-old concept.
Mm-hmm.
Medicine per se existing as a kind of magic word is no more possible with all the technology we have today, with all the technology that we can expect for the near and far future, and with the fact that as soon as we better understand how our machinery is made, we need more support even from other sources. So medicine, yes, of course, is it represents the conclude the final act of a number of things, of a mosaic of things. I think that this is medicine today.
Okay.
And so we need something to maybe also some other tools in the future to help this process.
Mm-hmm.
Okay.
Okay, great. Thank you very much. I'm afraid we've come to the end of our time, but yes, thank you very much for joining me today. It's been really interesting learning about your work.
Thank you, Philippa.